Hello, everybody. So I'm Zenon Demeter, and this is Diego Toquinto, and we are representing the University of New Mexico with a project titled Advanced Haptic-based Tele-operation of an Unmanned Ground Vehicle. Fancy way of saying that we got to play with robots. So we work closely with a company out of Toronto, Canada called Quanser. And Quanser is a company that's dedicated to working with academic institutions, instructors, and researchers to teach advanced topics in mechatronics, robotics, communications, and controls. So our project helped Quanser explore a new way to market their educational products and allowed them to challenge the way that controls and robotics are currently taught. Our project was divided into two parts. So in part one, we use these products to implement a control platform that utilizes remote operation, system feedback, and haptic response in order to control their Qbot 2, which you can see on the screen. In part two, we took this control platform and applied it to a simulation made in Unreal Engine 4.
Due to the broad scope of the project, we had a lot of features to implement and design challenges from the beginning. We implemented communications between our controller and our robot using TCP/IP over Wi-Fi. The controller, we had to lock it to 2 degrees of freedom instead of being able to use all 6, and we used those control inputs to implement the differential drive. We configured the controller origin point and made our drive system foot pedal enabled, and we used the onboard DC motors to return the control arm to the origin when the user lets go. Also central to this project, and maybe the biggest, most important part, was the implementation of haptic feedback. We used 2 forward-mounted IR sensors to provide proximity feedback from obstacles in the robot paths, and we used the bumper sensors in case those failed. We used the depth sensing system of the robot to let the user know when it got within 10 centimeters of an object, and we used the onboard gyroscope to provide information about the robot's stance. And then we simulated all of that. Using the Unreal Engine 4, we developed a level with obstacles and simulated a version of the Qbot. We simulated all 3 of our sensors, and then we integrated the sensor feedback into our existing control model.
So for a company like Quanser, finding and developing new ways to further engineering education is vital to their business platform. So it's especially important when they are able to utilize existing products. So the technology that we developed in this project has very far-reaching implications in a variety of engineering fields. And we do feel that the opportunity to work on a project as robust as this as undergrads has better prepared us for our engineering careers. So thank you, and any questions?
You said you simulated the sensor.
We did.
How?
So in Unreal Engine, you can use ray tracing. So we use that to simulate the IR sensors. There's also triggered events. So we placed those on the front of our Qbot model. That simulated the bumper sensors. And then in order to get the inclination, we didn't actually have to simulate the gyroscope, which we used on our physical robot. You can define planes in Unreal Engine. So you have one for the model, one for the level, and then use geometry to figure out the angle.
Did you guys write the drivers for the Unreal Engine?
We worked closely with a Quanser representative to write those. So
That's tough.
it's tough stuff, yeah. It takes years of experience. So he helped us with that, but we did implement some features in there too.
Sweet.
Anyone else? All right. Thank you.